All right, today we're diving into something that is, no joke, completely changing the game for AI. We're talking about making it smarter, way more accurate, and honestly, a lot more trustworthy. It's called a retrieval augmented language model, and it might just be the fix for one of AI's biggest and, let's face it, most embarrassing problems. You know the feeling, right? You ask a chatbot a question, and it spits out an answer that sounds so confident, so plausible, but it's just plain wrong. It invents a fact, maybe cites a book that was never written, or gives you information that's like 5 years out of date. It's a massive issue. In the industry, they call it hallucination, which is just a fancy way of saying the AI is making stuff up. And on top of that, its knowledge is basically frozen in time, and it really struggles with super specific, niche topics. The root of all this, it boils down to one simple analogy. A standard AI is taking a closed book exam. It only has access to what it was forced to memorize during its training. That's it. So that leads to the big question, doesn't it? If the problem is a closed book exam, what's the obvious solution? What if we just gave the AI a library card and let it look things up in real time? Well, that is exactly what a retrieval augmented language model, or RALM for short, actually does. It's a clever system that basically bolts an external library onto a standard language model. So before it even thinks about writing a response, it goes out and finds the latest, most relevant info on the topic. The best way to think about this is to compare two types of memory. A normal LLM has what we call parametric memory. Everything it knows is just baked right into its programming. A RALM, on the other hand, uses semi-parametric memory. It has its own internal knowledge, sure, but it also has the power to access external information whenever it needs to. It's literally the difference between a closed book exam and an open book exam. Okay, so how does this thing actually work? Well, it's a brilliant two-part system. First, you've got the retriever. Think of it as a super fast genius librarian. When you ask a question, its only job is to scour the internet or a huge database to find the perfect, most relevant documents. Then you've got the language model, and that's our writer. It takes your original question, smashes it together with all the fresh info from the retriever, and then writes a single, smart, and totally up-to-date answer. But you know, the way this librarian and this writer team up, it's not always the same. There are actually a couple of key ways they can interact. The most straightforward way is what we call sequential interaction. It's simple. First, the librarian searches. Then, the writer generates the answer based on what was found. Search, then generate. Easy. But there's also a cooler method called parallel interaction. This is where the AI tries to answer from memory and searches for external info at the exact same time. Then it cleverly weighs both of those outputs to create the best possible final answer. Now, our librarian, the retriever, has a few different tricks up its sleeve for finding info. The most basic is sparse retrieval, which is pretty much just a classic keyword search. But then you have dense retrieval, which is way more advanced. It searches for documents based on the actual meaning behind your question, not just the specific words. And of course, you can get hybrid models, but honestly, a lot of today's systems just plug right into Google or Bing for live, real-time web access. And what about our writer? Well, here's where you'll see some familiar names. You've got your autoaggressive models, like the whole GPT and Llama families. They are amazing at generating that human-like text we see in chatbots. But you also have other types, like BERT, which is an absolute master at understanding nuance and context, or T5, which is a pro at really complex jobs like summarizing a huge document or translating languages. Okay, so we've got a genius librarian and a star writer working together in this awesome supercharged system. What does that actually mean for us in the real world? What can this thing do? Honestly, the list of applications is just incredible. We're talking about everything from ridiculously accurate question-answering systems and fact-checkers to chatbots that actually feel like they understand the conversation. It's a game changer for writing code because the AI can access the newest programming libraries. It can even be used for generating images. If you ask it to create a picture of something super rare, it can go find examples first to learn what it looks like before it starts drawing. How cool is that? But look, this technology isn't a magic wand. It's powerful, for sure, but like any big leap forward, researchers are still working out some pretty major kinks, and there are 3 big ones you should know about. First up is robustness. If the librarian happens to grab a bad source, something that's irrelevant or just plain wrong, it can actually confuse the AI and make the final answer worse. That leads right into the second problem, retrieval quality. It all comes down to that classic saying, garbage in, garbage out. If the retriever can't find good information, the writer has nothing good to work with. And finally, building and running these systems is no small feat. They can be incredibly complex and require a ton of expensive computing power. But even with those hurdles, the verdict is in. As the researchers Han and Liu put it in their 2024 survey, which is the source for our explainer here, the integration of RALMs represents a significant advance in the capabilities of NLP systems. Make no mistake, this isn't just a small step forward. It's a huge leap in how AI understands and uses information. So, if there's one thing to take away from all this, it's that we're shifting from an AI that has to memorize everything to an AI that just needs to know how to find everything. It's a powerful change that points to a future where AI is way more accurate and capable. And that just leaves us with one final exciting thought. Now that AI officially has a library card to all of human knowledge, what are the truly mind-blowing questions we're going to ask it next?